we look at the example shown below. Let's check this. And the determinant is usually denoted by, if you have I, then the determinant of I, determinant of this I will be denoted by this. So when we see something like this, we are talking about determinant. And if we are to find the determinant of this 2 by 2 matrix, then we will have it as 1 times 1 minus 0 times 0. So how do you calculate the determinant of this? Use this to multiply this. You now subtract it from this multiplied by this, and that is how to determine the determinant. So if you have A11, A12, then we'll have A21, A22. The determinant of this, let's say this is the matrix, then the determinant of this matrix, which is, it can be denoted as DA or something like this. So it will be equal to, you use it to multiply this A11 times A22 minus A12 times A21. That is how to determine the determinants. So let's see some examples to justify the concept of determinant. These are the 2 examples to justify the concept of determinant. We have a 2 by 2 scenario. Here we have if A equals to 2, 3, 4, 1, find this. If you have to find this symbol represents determinant. So when you see this, it means determinant of A. And since this is a 2 by 2 matrix, automatically if you have to find the determinant of this, what you just need to do is to write it 2, 3, 4, 1. Then we use it to multiply this, and we use it to multiply this. We find the difference, and that is what is known as determinant. So we have 2 times 1 minus 4 times 3. So here we have 2 times 1, 2 minus 12. So automatically we have minus 10. So therefore determinant of A will now be equals to minus 10, and that is the answer. So in the case of 2 by 2 matrix, to find the determinant is easier. But in the case of the 3 by 3, just like this one for the example 2, we have to be very careful when we are trying to determine determinants of 3 by 3 matrix. So the simple way, or the way to solving or to resolving the determinant of 3 by 3 matrix is by having this. So you have, since you have x to be 5, 2, 1, 0, 6, 3, 8, 4, 7. So if you have to find the determinant of this x, what we need to do is to, you have a vertical line like this. So to continue from where we stop, we have 5, 2, 1, 0, 6, 3, 8, 4, 7. So what we need to do is to draw that vertical line. Then we write out our entry: 5, 2, 1, 0, 6, 3, 8, 4, 7. Now, if we want to determine the determinant of this, it calls for logic. And what we do first is we assume that this is plus, this is minus, and this is plus. This should be noted. We must not put our minus position here. It has to be at the middle of plus and plus. The technical way of doing this is we pick this. When we are picking this plus 5, then we close this and close this. We close this. We close this and we close this. So if you do it the way I have prescribed, you will discover that when you close this and you close this, you'll be having a 2 by 2 matrix. And the 2 by 2 matrix we'll be having will be 6, 3, 4, 7 for the first case. The second case will pick minus 2. minus 2. Then we have, when we pick the minus 2, we close the middle and we close this. We close this and we close the middle. So we have a 2 by 2 method 0387. 0387. That is what we are going to have. Then the third case, we pick +1. Pick +1 here. Then we close this. We close this. We close this. When we close this and we close this, when we close this and we close this, we'll definitely be having 0684. 0684. And now we have result to 2 by 2. Then 2 by 2 now we can solve the 2 by 2 directly. So we're saying +5. This multiplied by this, that will be 6 times 7 minus 3 times 2 times 4 for the first case, minus 2. Then this one will be 0 times 7 minus 8 times 3. Then this one will be +1 plus 1. Then this one will be 0 times 4 minus 8 times 6. Close it. Then this one will be +5. 6 times 7, 42. Minus 3 times 4, 12. Minus 2 into 0 times 7, 0. Minus 8 times 3, 24. Plus 1. 0 times 4, 0. Minus 8 times 6, 48. So automatically here we are going to have +5. 42 minus 12, that will give us 30. Minus 2 into minus 24. Then this one will be +1 into minus 48. So this one will be +5 times 30, that will give us 150. Minus 2 times this, that will be +48. +1 times this, minus 48. So +48 minus 48, that becomes 0. So we have 150. So definitely, therefore, the determinant of our x will definitely be equals to 150.
Application of linear and quadratic equations. Revision of solution of linear and quadratic equations. In the SS2 class, we've been able to deal with linear and quadratic equation effectively. We say a linear equation, we are talking about equation whose the degree of our x is 1. So we say this is a linear expression, then when we have an equal sign, then it becomes a linear equation. But when we talk about quadratic equation will be of this form, such that on the board, this example 1 is a typical example, and you have a solve the simultaneous equations. You are given this. This one is linear, this is quadratic, because the highest power of your y here is 1, or highest degree of y is 1, and the highest degree of y is 2. So we have equation 1, 2x minus y equals to 10. Let's call this equation 1. Then 3x plus y squared equals to 22. Let's call this equation 2. Here, from equation 1, I can have y to be equal to, by making y the subject of the formula, I have 2x minus 10. So what I did here was to transfer this y to this, and I took this 10 to the other side. Then I have y equals to 2x minus 10. So in that situation, then let's call this equation 3. So I now want to substitute this equation 3. Substitute equation 3 into equation 2. That is what I intend to do now. And if I substitute equation 3 into equation 2, I will have 3x plus y squared, and my y is this, so it becomes 2x minus 10 all squared equals to 22. So the next thing I will do here is to expand this. So I have 3x plus, if I expand this, I will have 2, these 2, I put it on this, then it becomes 4x squared. 2 times 2x, then I'll have 4x. 4x times this, that will become minus 40x. Then minus 10 squared, that will become plus 100 equals to 22. So if you don't know how to expand using this method, you can expand this, but this is going to be rigorous and time consuming. That is why I expand it this way. If I expand this time this is 4x squared. This time this minus 20x. This time this minus 20x. This time this plus 100. And that will be 4x squared minus 40x plus 100. And that is not different from what I got. Then here you have, so to rearrange this, I have 4x squared minus 40x plus 3x, that becomes minus 37x. Then this one becomes, we bring this to the other side, you have plus 100 minus 22 equals to 0. So automatically this one will be 4x squared minus 37x plus, that's 78 equals to 0. So this is a bigger figure, so I can resolve this by using the formula, using the